Hey guys, thanks for joining me for the notes for lesson 5.3. Um, these note guides may look different than what you have in front of you unless you were in class and got the new updated note guides. That's okay. Mostly we just took away some stuff to make it a little simpler. The only thing we really added was this piece here, which you already have in your note guide in 5.1. So if you have the old version, you're not missing anything, and anything that you don't see on my screen, you can just cross out. So as a review kind of in this unit so far in 5.1, we've learned about the three different forms of quadratic functions and the key information that we can get from each form. So in polynomial form, we can find the y-intercept and easily. We can find other things, but that's what we can get easily. In intercept form, we can find our x-intercepts easily. And in vertex form, we can get our vertex form, we can find our vertex easily. We haven't talked about it a lot, and we'll go over it today. We also can find the axis of symmetry. So, and then in 5.2, what we did is we converted from polynomial form to vertex form using a process called complete the square. So today in 5.3, we're going to kind of bring it all together and practice converting quadratic functions between all three of the different forms, and then use the most convenient form to identify each key feature of the function. So in other words, no longer are you going to have to try to find the vertex or the x-intercept from polynomial form. You can use the easier form to find them, as long as you can convert to that form. So the great thing about this lesson, besides that, is that we aren't really adding anything new. We're just making connections between different things you've already learned. And hopefully for those of you that are still struggling, especially with 5.1, it's going to help kind of bring it all together and make it click. I'm not going to spend a lot of time in the notes section because, like I said, there's not really anything new. This piece right here, you already have in your notes. We just put it here as a handy reference. And then this piece up here is just there. It just shows you how to go from one form to another. So you actually already know how. It just reminds you how to do it. So for example, if you want to go from vertex form to polynomial form, then you multiply and simplify. If you want to go from polynomial form to intercept form, then you're going to factor two binomials. So everything in these little circles you should already know how to do. And don't worry, we'll practice and we'll go over them. But this graphic is just a reminder to help you remember which one to use. One thing I do want to point out, though, is that you cannot go straight from vertex form all the way to intercept form. You have to go through polynomial form first and then intercept form. And likewise, you can't go straight from intercept form to vertex form. You're going to have to go to polynomial form first and then vertex form. So that's not really a problem because we're going to be finding all three forms. So it just is going to dictate which one you find first. So if you're given vertex form first, you're going to find polynomial form, and then you're going to find intercept form. All right, so let's go ahead and get into the examples. So let's start with number one. Well, let's start with A. There only is one example. Okay, so part A is in polynomial form. And so let's go back up and look at our graphic. When we're in polynomial form, this is where we actually get a choice if we want to go to vertex form or if we want to go to intercept form. Since we most recently did in lesson 5.2 completing the square, let's go ahead and do that. All right, so to complete the square, if you guys remember, first we're going to find half of b, which equals 4, and then we're going to square that half and get 16. And we're going to take our function and add our square and subtract our square. Keep everything else the same. And then right here, this is our perfect square, so we can rewrite that as x plus 4 squared. And then we'll take what's left over at the end and combine those terms to get minus 25. So now we have our equation in vertex form. All right, I'm going to color code these. All right, while we're here in vertex form, nope, let's just keep going. So let's go to intercept form next. And to get to intercept form, we have to be in polynomial form. So I'm going to rewrite my equation in polynomial form here. F of x equals x squared plus 8x minus 9. All right, so let's look at our chart at the top. To get from polynomial form to intercept form, it says we're going to factor to two binomials. All right, so the method we're going to use to factor is we're going to use the big X. It doesn't really make sense to use the quadratic formula because that's just going to give us, it's going to give us our intercepts. It's not going to give it to us in factored form. So we're going to need to actually factor, which means we're going to use our big X. I know some of you are a little nervous to use the big X, but the ones in these problems are going to work out really well. So we'll go through some examples, and none of them are going to be tricky. They're going to be easy. So don't worry, we're gonna get through it together. So we look at our C here, and that goes up here, -9, and then our B goes down here, or 8. So two numbers that multiply to -9 and add to 8. So I'm gonna have 9 and 1, and one of them has to be negative, and it's gonna be the 1. So let's see, 9 times -1 is -9, and 9 minus 1 is 8. So there we go. So then we write it f of x equals x plus 9 and x minus 1. And now we have our equation in intercept form. All right, so now we have our three different forms of our equation. Same equation, three different forms, but we're going to use each of those forms to find the piece of information that's easiest to find from that form. So in our, we were just in intercept form, so let's start there. In our intercept form, we can find our x-intercepts. So our x-intercepts, they are at these points P and Q. And remember, it says we have to use the opposite because if you see in our equation, they're negative right here, but then when you write them as points, they're positive. So we have to take the opposite of them. And you guys should be remembering that because we've been doing that a lot. So we have two of them, and they are going to be -9, 0 and +1, 0. So those are our x-intercepts. And then let's go up to our polynomial form here. In polynomial form, we find the y-intercept at that point 0, c. So our c is -9. So our y-intercept is going to be at that point 0, c, or in other words, 0, -9. And then last but not least, we have our vertex form, which, as you know, is great to find our vertex. So our vertex is going to be at the point -4, -25. And remember, we're always going to flip the ones in the parentheses. So that 4 got flipped, and then this 9 and -1 got flipped. And you can see that when you look at the equations, it's because those are always negative in their equations. And so when they're negative, we use the opposite for them. So it'll say that in those boxes. If you're confused, you can look at your notes, and it will tell you to use the opposite. The last thing, and like I said, we haven't talked about this much, but we're going to go over it. The last thing we can get from vertex form is the axis of symmetry. Oh, there should be another M in there. Okay, so the axis of symmetry, and it says right here in this box, the axis of symmetry is at x equals h. So let's just go ahead and write that first. X equals h. And what is our h? Our h is the opposite of that. So our h is -4. So our axis of symmetry is at -4. Another way to think about this is the axis of symmetry. Well, if we have a parabola and it has a vertex, the axis of symmetry is a line that goes right through the vertex. And in this case, our vertex is at the point -4, -25. And so it's a line that goes through that point. And since it's a line that goes up and down, it's going to be a line that's going to be x equals, and then whatever that value of that x of the vertex is. So it'll be x equals -4. But the easy way to do it is to just look at the information in the box in vertex form. The axis of symmetry is that line x equals h. All right, I'm going to erase this little sketch because we are going to do a better sketch. All right, so let's see. Let's draw some axes here. All right. Okay, so let's start with our vertex. I think that's the easiest place to start. It says our vertex is at -4, -25. I'm going to count each of these as 5. So 1, 2, 3, 4, 5. So our vertex is going to be approximately right there. And then our x-intercepts are going to be at -9, so like right there, and +1, so about there. And our y-intercept is at 0, -9, so about right there. So we can connect our dots to draw our parabola. And we have a sketch approximately like that. So our vertex down here, our y-intercept here, and those are our two x-intercepts. Okay, all right, so your sketches don't have to be great, but I want those 4 points on your sketches. All right, so I'm going to go ahead and erase this one. Remember, you can pause the video at any time to make sure you have your notes copied down. Remember to copy it down in your notes because you can always go back and look at it later to help you. All right. Okay, so let's do part B of the example. So part B, we are starting with an equation in vertex form. So looking up at our chart, when we're in vertex form, we really only have one choice, and that is to go to polynomial form. So that's what we're going to do. So to go to polynomial form, we actually did some of these in lesson 5.2 as well, those last problems at the end. And so for those of you that remember, if not, that's okay. I said there were kind of 3 steps. The first step is going to be we have to expand this square. So this x plus 4 squared. Order of operations, you got to take care of that piece first. So x plus 4 squared is the same as x plus 4 times x plus 4. And so we're going to, you can use our trick-or-treating method or our box method or however you want to do it. And we're going to get x squared plus 4x plus 4x plus 16. We can combine like terms, x squared plus 8x plus 16. And again, this piece right here is just this right here. So now that we've taken care of that piece, we can come back and do everything else. We still have that -2 in the front and this +8 out there. So now we can distribute this -2 to each of our 3 pieces and then add our +8. So we'll have -2x squared minus 16x minus 32 plus 8. So we'll have -2x squared minus 16x. Combine those 2 terms, and that will be -24. So this right here is our function in polynomial form. All right. So the last thing we have to do is we've got in vertex form, we have polynomial form, so now we can put it into intercept form. So looking at our chart to get to intercept form, we have to factor into 2 binomials. So remember, we're going to use the big X for this. Something I want to point out is that we do have an A in this case, this -2. And I know that's often why some of you are scared to use the big X is because there's an A. But before you factor with the big X, you need to check to see if you can factor that 2 out. And what I mean by that is all 3 of these terms are divisible by -2. So we can bring that -2 out in front. We can factor it out of all of our terms. So we bring it out front, kind of like the opposite of distributing. So when we divide -2x squared by -2, we're left with x squared. When we divide -16x by -2, we're left with positive 8x. And when we divide -24 by -2, we're left with positive 12. So what we did is just kind of backward of distributing. I know some of you it's been a while since you've done factoring out, so that's kind of how that works. So now that we've done that, now we can do our big X, and now it's an easy one. So we're looking for our C on the top, 12, and our B, 8 in the bottom. So two things that multiply to 12 and add to 8. And I'm thinking 6 and 2. So then we'll write that as x plus 6 and x plus 2. And we still have our a in front, so we'll still write that there. So now this is our function in intercept form right here. All right, so now that we have all three forms, we can find our key pieces of information, our key features. So I'm not going to scroll back up to the chart because I hate scrolling back and forth, but let's start with intercept form. We were just there. In intercept form, we can find our x-intercepts. So our x-intercepts, there's two of them, and they're going to be at those points p comma 0 and q comma 0, and our p is -6, and our q is -2. Remember, we had to do the opposite of those numbers. And then from our polynomial form, we're going to find our y-intercept. And that is going to be at the point 0 comma c, and our c is -24. So once you're in the right form, see how all of this information is just so easy to get out of all these forms. Our vertex, we're going to look at our vertex form, and it's going to be at the point -4 comma 8. And then we will also find the axis of symmetry, and it will just be at that line x equals h, so x equals -4. All right, so we have all of our key pieces of information, and now we can graph it. All right, so starting with our vertex, okay, so we're starting about right here. Our vertex -4, -4, +8, and then our x-intercepts are at -6 and -2, and our y-intercept is at 0, -24. I'm not going to draw that, but it's going to be way down here somewhere. So our parabola is going to look something like this. It's going to go down like that. If you notice, this parabola opens downward, which makes sense because our a in all of our forms is -2. So our a tells us if it's going to open down or up, and it's negative, so it's going to open down. All right, let's move on to the last example. So pause if you need to copy anything down before I delete it. All right. So our last example, we are starting in intercept form. So when we start in intercept form, we only have one choice. We have to go to polynomial form first, and we're going to do that by multiplying and simplifying. So we're going to use the trick or treat method to do that. X plus 3 and x minus 5. So x times x is x squared. X times -5 minus x, 5x. 3 times x plus 3x and minus 15. Okay, I'll go back. Okay, x squared minus 2x minus 15. And that is it. That was pretty easy. Sometimes it's a little bit more complicated if you were, for example, let's say I had a 2 out in front here. In that case, I would still do everything that I did here. I would still do all of this the same, exactly the same. And then once I got to this point, then I would distribute my 2. Kind of like we did in example B, where we expanded our square first and then we distributed our -2. Same thing. Do your foiling or your trick-or-treating or whatever you call it first, and then take care of that A in front. Leave it to the end, and that's the best way to handle that if you have a number like that. But in our case, we don't, so we don't have to worry about it. All right, so this is now in polynomial form. And now that we're in polynomial form, we can go to vertex form. And again, the way we do that is by completing the square. I don't want blue. Okay, so we're going to find half of b. Our b is -2. So half of that is -1. And then the square of our half is -1 squared, or -1 times -1, which is +1. So we take our function and we add and subtract that square. So add 1, subtract 1, keep everything else the same. This part right here is our perfect square. So we can rewrite that as x minus 1 squared. And then we take what's left over, combine it, -16. All right, so now we have our function in vertex form. So again, we have our three different forms, so now we can get our key information. So we finished with vertex form, so let's find our vertex first. Our vertex will be at the point 1, -16. I'm not going to write these. Oh, I'll write them down. Okay. Vertex at 1, -16. And our axis of symmetry is going to be at x equals 1. All right. And then from polynomial form, we find our y-intercept. And it is at the point 0, c. There's our c right there. So it's at the point 0, -15. Our x-intercepts, we have 2 of them. They are going to be at, we're going to look at our p and our q. So they're going to be at the points -3, 0 and +5, 0. All right, so we have all of our information and all of our forms. So now it's time to graph it. Start with our vertex, 1, -16. So let's go 1, 1, and then that's about 5, I'll go down to about here, 16. Okay, and then our x-intercepts are at -3 and +5. So 1, 2, 3, +5 about there. And then our y-intercept is at 0, -15, so right there. All right, let's connect our dots. Not the prettiest parabola, but it works. It's just a sketch, so those are our points. We have our 4 points and our sketch of our graph. So that is the process you will do for your homework. Let's go ahead and look at the homework now. Again, if you have the old notes and the old homework, this will look a little different. But basically, we mostly just got rid of things. The only problems that you need to do are problems 1 through 4. Everything else you can cross off. And again, we only added a little bit. On the original homework, you only needed to sketch for problem number 1. Now we want you to sketch for problems number 2 and 3 as well. So if you have the old homework, you might have to just do that on a separate piece of paper because there won't really be space. Same process we did. You are going to write each function in the other 2 forms. So you should end up with 3 forms for each function. It gives it to you in one, write the other 2, and then identify those 4 features. You want to make sure you're identifying the x and y intercepts, the vertex, and the axis of symmetry, and then go ahead and sketch graph. So good luck, and we'll see you in class. Thanks, bye.